Example number 2 for section 1.6 asks, where does the tangent line to the graph y is equal to the square root of x at x equal 2 cross the x-axis? Okay, so the first thing we need to do is we need to figure out what the graph, or what the line, or equation of the line that is tangent to the graph at x equals 2, what that is given by, what function is it. So let me just give you a rough sketch of this. If I graph the square root of x, that looks something similar to this. So at x equals 2, it has a height of square root of 2. It has a tangent line that looks something like this. And the question is, what they want to know is, what is this guy right here? Where does it cross the x-axis? Okay, so we got a couple things to do. The first thing we need to do is figure out what the equation of this yellow line is. And so what we're going to do is find the slope of the yellow line. So the slope of this yellow line, let me do it in yellow here, that way I stay consistent. Okay, that is found by taking the derivative at the value, the x value. So we need to find f prime at 2. Well, f prime of x is equal to d dx of the square root of x. So I'm mixing notations here again, so if you want to write this as dy dx, that's fine. So the derivative we know of the square root of x with respect to x is 1 over 2 square roots of x. So what that means is that if we want dy dx evaluated at 2, these are the same notation for the same thing, but different notations for the same thing. That gives me 1 over 2 square roots of 2, which is square root of 2 over 2 times 2, or square root of 2 over 4. So the slope of this line, the m value, is equal to the square root of 2 over 4. So we know that we have that for the slope. Now we also know that we have the point 2 comma square root 2 falls on both the blue line and the yellow line. So we want it for the yellow line, so we're going to do y minus y1 is equal to m times x minus the x1 value. So what I've done is I've taken square root of 2 over 4, multiplied it in by 2, so the 2 and the 4 cancel to give me 2 down here. So this is y is equal to square root of 2 over 4x, okay, minus square root of 2 over 2 plus square root of 2. There we go. Now get a common denominator here. Like that. Okay. So this right here is it's not the final answer. That's the equation. Oops. That's the equation of this line right here. So what we need to do is to figure out where it crosses the x-axis, is we need to set the y value equal to 0 in that. So 0 is equal to, so this is the guy we're looking for. I'm just going to multiply everything by 4. And if I do that, I get 0 is equal to the square root of 2x plus 2 square roots of 2. That just clears my denominator. I don't have to deal with with a fraction anymore until the very end here. So I'll move this guy over, and then we'll divide both sides by square root of 2. And so these guys are the same number, they go away. So I have an x value that's going to be equal to -2. So the actual ordered pair, the point that it hits is at -2, 0. Now what we can do is we can check that, right? Okay, so let's go ahead and let me pull up a website here for you. So we've got the original equation is y is equal to the square root of x. That's that guy right there. Let's go ahead and at 2 we want the tangent line, so let's go ahead and put our equation of our tangent line in there, which it was pretty ugly, but we ended up with, let's just take a look here, square root of 2 over 4x. So y is equal to the square root of 2 over 4 times x plus the square root of 2 over 2. Okay, and now if you look, clearly it's tangent here, and it intersects back here. And so we've just went ahead and we've verified that our solution is correct.